Hello everyone, in today's video we're going to understand the complete control wiring and perform the step-by-step interconnection between an ABB 33 kilovolt vacuum circuit breaker and a Siemens Feeder Protection Panel. Whether you're commissioning a new substation, carrying out maintenance, or troubleshooting a circuit breaker control circuit, this video will help you understand the complete wiring logic from start to finish. For this demonstration, we're referring to the official ABB VCB instruction manual num 1 VYN 40190-073 and a standard Siemens 33 kV triple feeder protection panel drawing. Before we begin, here's an important safety note. This video is intended for qualified electrical engineers, technicians, and commissioning personnel. Always follow your site's lockout-tagout procedures, use approved project drawings, and verify every terminal number with the manufacturer's documentation before energizing any circuit. Also remember one important rule while reading breaker schematics. Always study the drawing with the circuit breaker in the open position and the closing spring discharged. Keep in mind that terminal numbers and wiring arrangements may vary depending on the breaker model and project specifications. With that said, let's begin. AC supply wiring. Our first step is energizing the breaker's internal auxiliary circuits. The AC supply powers the spring charging motor, space heaters, cubicle lamp, and service socket. Connect the AC phase to terminal XDB101, H1. Connect the neutral to terminal XDB102, H2. Now install jumpers from XDB101 to XDB103, H3, and from XDB102 to XDB104, H4. These jumpers distribute power to the internal heater, lamp, and service socket. As soon as the AC supply is switched on, the spring charging motor starts automatically through the limit switch and charges the breaker closing spring. Once the spring is fully charged, the motor automatically stops. Next comes the DC control supply, which is the backbone of the protection and control system. Connect the DC positive plus to terminal XDB105, J1. Connect the DC negative minus to terminal XDB106, J2. With both AC and DC supplies available, the breaker is now energized and ready for functional testing. Let's now understand how the breaker closes in local mode. Turn the local remote switch to the local position. This closes the local contact and routes the DC positive from terminal J1 to point K3 on the TNC switch. When the TNC switch is turned to close, the positive supply moves from K3 to K4. The current now passes through the anti-pumping relay KFN1. Since the relay is de-energized, its normally closed contact allows the positive supply to continue toward K5. Next, the circuit checks the breaker auxiliary contact BB1. Because the breaker is currently open, the normally closed auxiliary contact remains closed, allowing the supply to reach K6. Since the spring was charged earlier, this contact is closed. The DC positive reaches one side of the closing coil, while the DC negative is already connected from J2. The closing coil energizes and the vacuum circuit breaker closes. Immediately after closing, the breaker auxiliary contacts change state. The normally closed contacts open, removing power from the closing coil. This prevents the coil from remaining energized, even if the operator accidentally holds the TNC switch in the closed position. Now let's see how local tripping works. Keep the local remote switch in the local position. Turn the TNC switch to trip. The DC positive is routed to K10 and then to K11. Since the breaker is now closed, the normally open BB1 auxiliary contact has changed state and is now closed. This allows the DC positive to reach the trip coil. The trip coil energizes instantly, causing the breaker to trip open. At this point, we've successfully verified both local closing and local tripping operations. Now let's connect the breaker to the Siemens protection panel for remote control. Connect Siemens terminal 3XCB16, 3K11 to breaker terminal XDB109, K9. This provides the remote close permission path whenever the local remote switch is in the remote position. Internally, the Siemens panel verifies that both trip circuit supervision relays are healthy and that master trip relays 86 and 96 are reset. Once these conditions are satisfied, the DC positive reaches terminal 3xCB17, 3K119. Remember to short terminals 3xCB17 and 3xCB18 at the panel. When a remote close command is received from SCADA or the Bay Control Unit, relay 52AB operates. The relay sends the closing pulse through Siemens terminal 3xCB19, 3K23. Connect Siemens terminal 3xCB19 directly to breaker terminal XDB110, K4. Quick tech tip, if you try remote closing at this stage, it probably won't work. That's because the Siemens panel still expects the trip circuit supervision loop to be healthy. Let's wire that next. Trip circuit supervision ensures that the trip circuit remains healthy whether the breaker is open or closed. Connect Siemens terminal 3xCB9, which is the pre-close supervision point, to breaker terminal XDB112. Connect Siemens terminal 3xCB8, the post-close supervision point, to breaker terminal XDB111. If your breaker uses dual trip coils, repeat the same wiring for trip circuit number 2 using the corresponding spare terminals. With the supervision loop completed, the panel now recognizes a healthy trip circuit and permits remote operation. For remote tripping using the panel TNC switch, connect breaker terminal XDB113, K14 to Siemens terminal 3xCB20, 3K25. Then connect Siemens terminal 3xCB21, 3K27 to breaker terminal XDB14, K11. The panel can now trip the breaker remotely. Now let's wire the most important circuit in the entire control scheme, the protection trip circuit. Unlike manual operations, protection tripping must never depend on the local remote selector switch. Whenever an overcurrent, earth fault, differential, or any other protection operates, the breaker must trip immediately, regardless of the operating mode. Inside the Siemens panel, terminals 3xCB4 and 3xCB5 provide the internal DC control supply. Install a shorting link between terminals 3xCB4 and 3xCB6. When master trip relay 86 or 96 operates, its contact closes and extends the DC positive to Siemens terminal 3xCB7. From here, wire Siemens terminal 3xCB7 to the breaker's protection trip interface terminal exactly as shown in the approved project schematic. In many ABB VCB configurations, this interfaces through terminal XDB111. However, terminal assignments may vary depending on the breaker model, customer specification, or project design. Always verify the manufacturer's manual and the approved wiring drawings before commissioning. Finally, let's wire the breaker status indication so the control room, SCADA, or Bay Control Unit always knows the breaker condition. Spring charged indication, apply DC positive to breaker terminal XDB109. The output from XDB120 becomes the spring charged status signal. Connect this output to the designated digital input on your protection panel. Breaker open indication. Apply DC positive to breaker terminal XDB121. Take the output from XDB122 and connect it to Siemens terminal 3xCB2. Breaker closed indication, apply DC positive to breaker terminal XDB123. Take the output from XDB124 and connect it to Siemens terminal 3xCB3. The control panel can now correctly display whether the breaker is open, closed, and whether the closing spring is charged. And that's the complete control and protection interconnection between an ABB 33 kV vacuum circuit breaker and a Siemens Feeder Protection Panel. By understanding the AC supply, DC control circuit, local operation, remote operation, protection tripping, trip circuit supervision, and status indications one step at a time, commissioning and troubleshooting become much easier. If you'd like a dedicated video explaining trip circuit supervision in detail, let me know in the comments below. If you found this video helpful, don't forget to like, subscribe, and turn on the notification bell so you never miss future substation engineering tutorials. Thank you for watching, and I'll see you in the next video.